Welcome back to my Commodore 64 Reverse Engineering video series about the shoot-'em-up construction kit. I'm very happy because I found the tape version of the shoot-'em-up construction kit that I remember. Now, there are several different tap files in the Commodore 64 tape archive, but I found this version on Rick's 64's C64 tape archive on archive.org, and this tape file contains the shoot-'em-up construction kit introduction, kind of like animating screen that I remember when I had the tape version of the shoot-'em-up construction kit, or SEUCK, on tape. There were several different versions. There were re-released versions, there were other versions that I used on the Reverse Engineering series of videos quite some time ago now, but this is the version that I remember. So let's have a deeper look at this particular version of the tape version of SEUCK. It has the introduction and it uses kind of like an auto run start method of jumping through the vector at 0326, and it starts executing code at 351 almost immediately. The file is called introduction, and it's loading, well, it's already loaded some code inside the tape buffer, of course, which is the standard way of doing it, but it's just got this very simple piece of code here which loads an extra block of data, and then down here we've got this jump all the way pretty much at the beginning of the 0 page, starting at 000A in hex, which is 10 in decimal, which is very low down in the computer's 0 page memory location. You can see there on the graphics map that it's already loaded a small block of memory, kind of like a memory page almost, using this screen and border on colored screen and border change turbo loader. So it's loaded this data page and it's got some extra code now which seems to jump around and JSI around into various different subroutines, just getting other tape turbo bytes, but using a different turbo structure or turbo data structure compared to the loader that just happens after the auto run loader. And then it seems to load page after page of data, so you can already see that after this page, the jump that seems to go back to the beginning of the turbo loader has just loaded 256 bytes, I think, roughly approximately, into the memory location of 400 in hex, which is the default memory location of the default screen. And it's starting to display the introduction, congratulations on purchasing the one and only shoot-'em-up construction kit message there. So this loader is quite funny because it seems to load repeatedly small chunks of data, probably 256 bytes long. And then eventually, it actually jumps into a subroutine as well, into the code which was loaded as part of the tape header code load as well. So it's JSRing into that subroutine there, which seems to get 8 bits from the tape and then transform them into being a byte, of course, by using that ROR $05 instruction there, which rotates right the carry. And it's using the usual way of timing the pulses, using the CIA registers to time the pulses on the tape. So we're not really interested now in looking at what it's loading in minute detail, because we know that it's just using this second loaded turbo loader plus a bit of code which was loaded in the tape header. What we're really interested in, or what I'm interested in rather, and why I'm doing this video, is because this is going to show the color cycling screen that I remember when I had the tape version. And when I was doing the reverse engineering series of videos about SEUCK before, the version that I had in the tape archive, well, there was one working version, right, and then there was one version which was corrupted and didn't load. And I just wanted to have a quick little look at this introduction screen that I remember. So this introduction screen has loaded some data. Look, and it's got a graphics map and it's got character set information. But we've already got some reverse character set information plus some extra box graphics there. And back in the day, I remember looking at this character set and thinking, hey, those box graphics aren't used. And those waveforms to the left of the box graphics are also not used. Triangle, sawtooth, pulse and noise waveforms, right? They're not used in the introduction screen text at all, which I thought was quite interesting. When I was looking at this, when I was probably, I don't know, 13 or 14 years old at the time, it was like finding little hidden gems in character sets and in graphics data when you find this kind of unused stuff. So we can see when the real code starts for the introduction screen at A000 there, we can see that it's just basically using this reversed character set. It was making sure that all of the characters are in range by doing an AND with $3F in hex immediately, of course, which means that the character set of information is all normalized so that there aren't any out of range characters, so that all of the displayed characters fit the character set. And then we've got that nice little color raster bar cycling effect in the background. So it was a nice find, finding that original tape image there. The next file which was on the tape, I remember, was Slap and Tickle, and it uses the same kind of screen on, but with border and screen color change loader as well. And then it's got this little pulse of, sometimes there was a little pulse of color data there as it was loading the blocks. But yeah, basically this is the same kind of like start code. And then every now and again you can see that pulse of bright color bars appearing on the screen. There we go, there was another pulse there. So it's quite an unusual loader. I don't see this kind of loader, turbo loading code very often. Which is why I was interested in finding it. So when Slap and Tickle runs, it runs code which then starts at 810 in hex, which is 2064 in decimal. And then we have all of this loaded data. So this initially loaded code seems to be quite well compressed. So of course this code seems to be quite well compressed. So I'm going to save out the original compressed block of code that's been loaded from this specific version of the SEUCK tape file. And then I'm going to compare it with the version of the code that was on the other tape file that was from a different release of the shoot 'em up construction kit, because to see if there's any differences. Because, you know, I was reverse engineering this version of SEUCK, right? And I just want to really make sure that the different released versions of SEUCK have hopefully identical code. So when we get to the main menu, and it is highlighted there with edit sprites on the main menu. So now it's decompressed and it's actually running the start of the editor. Let's save out all of the memory as well, so that we can compare the decompressed memory with the decompressed memory of the other version of the tape, other tape version as well. So let's just save out all of the memory from 200 to FFFF all the way up until the end of memory. Let's reset the Commodore 64 cleanly. Let's find that other tape file version that does work on the C64 tape archive. So there we go. This was from the 1989 Toolbox release version of the shoot 'em up construction kit. Let's just reset the dataset control in the Vice emulator. There we go. Now it's actually starting to read. See, it's called message, not introduction, and it's just this basic code which starts, which tells you to stop the tape when the main menu appears. And this version of the tape has a very different turbo loader, right? I was warping through the tape loader, of course, we have this. I want to set a ranged breakpoint as well for the start of memory when it's actually loaded. But you can see it's loading memory in all sorts of different order and different chunk order as well. So even while it's loading chunks of data for SEUCK, it's not loading it in sequence from the start of memory until the end. It's loading data chunks in the middle of memory first. The screen is on and it's got SEUCK brackets, slap and tickle, and it's got this loading counter as well. So the screen is on rather than the screen being off and just having little color flickering going on. It's got the full screen on and loading indicator. And I can already see the beginning of the data in memory that's been loaded for SEUCK. It's compressed with TriLogic version 3.2, which is very much different to the compressed version of the code which was loaded, which started at 2064 without any TriLogic message. So actually, I'm not going to save the loaded data when it's sitting there compressed in memory, because I know that it's not going to compare as identical, right? Because it's using different compression methodology or different compression methods. However, I am going to save all of the data now that the TriLogic unfreeze code and decompression code has run. I'm going to save the whole of data now when it's at this state of being in the main menu. So I think edit sprites was the menu item flashing. Yes, there we go. So it's basically, the editor was starting in the same kind of state. So let's just use a nice binary difference tool just to see if there's a difference between the old version and the newer version that I remember in the decompressed memory. So we have some memory differences there at the beginning of the screen memory, and that was just the Commodore 64 logo. And we've got a couple of bytes difference there at 9E2, 4, 5, 6, 7, 8, was it? 4, 5, 6, 7, yeah, 9E28. So 4E05 compares differently there compared to the other two versions. We've got a byte difference there, which I think is inconsequential. And the rest of the memory seems to compare as practically identical, apart from here. Look, this is the Commodore 64 basic RAM bytes free message, Commodore 64 basic message at the beginning of, just at the beginning of the first couple of character rows of the screen. We're not really too worried about that. But yeah, I think the rest of the editor, plus all of the graphical data in this version of Slap and Tickle anyway, which is the demo game, one of the demo games released with SEUCK, I think it's practically identical. So I think we can say pretty much safely for sure that even though the tape releases were drastically different in terms of their tape turbo loader functionality and also the introduction menu, or the introduction screen rather, the actual underlying SEUCK release doesn't seem to have had any significant bug fixes or changes between the different released versions. So that's useful information anyway. It means that when I was doing all of the other C64 shoot 'em up construction kit reverse engineering effort, that I wasn't reverse engineering something that was wildly changed in a particular different release anyway. So that's good news. That's what I really wanted to check as well. Apart from having the little nostalgia trip of going back into my old memory from many decades ago now, it feels like, about this color animating introduction screen, right? Because I always liked this introduction screen from the tape version, because I really liked using SEUCK back in the day when I was oh so much younger than I am today. So yeah, we can see here, look at that code. It's just loading the data in the screen memory, look, and then ANDing it with 3F and then storing it back into the same location in the screen memory. And that AND with 3F just makes sure that all of the characters in that screen are the same. It then clears the color RAM at D800 in hex until DB00, DBFF rather. all with black, and that's because black is the actual color of the characters on the screen, but of course it shines through with the color, well, with the screen color changes. That was the other release that I reverse engineered, right? That was the other working tape release. It's not that. That's not the version that I had either. The version that I had was actually it had the very much different tape inlay. It was a clamshell case. I think it was a black, kind of like quite large form factor clamshell case. I think the actual graphics for that, the actual inlay graphics, are on the Lemon 64 website. Yeah, so it looks like this. It looked like that on the clamshell tape case. So that's the version. I didn't have that version. Definitely not. Definitely not that one, but not that one. I had the tape version. It looked like this. Yes, the tape looked like that. I think that was, that's the advertisement. But yeah, this kind of like stone shoot 'em up construction kit. Yeah, that's the version that I had on tape. Includes 4 free games. Star in the bottom right hand corner there. Yeah, it's always nice finding a specific release that you had, or I had rather, many years ago. So this is the broken version of that tape image on the tape archive. So it was called Introduction, but you can see when it's loading data, the data in the screen is skewed, it's offset, and it's not loading the correct data at the correct place. It seems to have missed at least the first 256 bytes from the introduction screen message, right? So there's no real hope. And you know, the character set information as well, look, it's all offset by a few bytes at least. So the character set information is wrong too. So comparing the working version of that tape image with the non-working version of the tape image, I see some differences in the length of the pulses. So these hex bytes here, generally speaking, most of the hex bytes that you see in these tap files are just pulse lengths divided by 8 machine cycles. So if you want to work these pulse lengths out in terms of precise cycles, machine cycles, then you take each of these numbers in hex, and I think you multiply them by 8 at least, if I remember correctly anyway. It's been a while since I've had a look at the tap file format, but yeah, these are basically pulse lengths. So the working version of that tap file has pulse lengths which are 20 and 41, for example. For this specific version of the data that's loaded. In the other file, the pulse lengths are sort of slightly different length, but I think it was missing out a whole chunk of data more than anything, or maybe there was a blank block of data in one tap file, which in the broken one didn't transfer across or something like that. This is why I think it's very important from a preservation point of view to include the raw tap file data before there's any cleaning done on it. From a preservation point of view, you want to make sure that you have a copy which is as precise and exact as possible from the data that's originally read in from the tape, so that if there's any kind of like errors in the translation when the raw data is being tidied up, then the raw data is still available to then reprocess and fix any problems that happen during kind of like a cleaning process. You know, from a preservation point of view, always include as much raw data as possible, as opposed to process data, because once you process the raw data, then it's no longer original. It's no longer usable from the point of view of preservation. But anyway, there we go. That's my 2 cents or 2 pennies worth of thought. So yeah, when I was looking through this, I could see some slight structural differences on the non-working turbo tape file data compared to the working turbo tape file data. So there we go. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel. or sending me a super thanks. They are always very much appreciated. Take care, have a great day, evening or night, wherever you are.